There, pandas are your friends. Tutorials. I should have said are our friends. Amigos. I do have some, if you're really wanting to learn more about data science, you don't have to go through all of them. If you really want to learn about data science, a lot of this goes further than we're going to go, but I put it in there for reference. We are going to do these first little parts. We're going to get stuff from CSV and JSON. We'll do some basic analyzing. Pandas is a very, very hugely popular library when you're doing data analysis. So I'm going to start at this part in the tutorial, which is on my GitHub, and you should already have a copy in your Colab notebook. When you go through the tutorial, take notes, copy code into your own Colab notebook. Take what's here and modify it to see how it works. Go above and beyond just, oh yeah, this is interesting, and yeah, okay, I got it all. That doesn't do anything. And I'm not making you type in a bunch of stuff, which is probably fine. So this tells us the version of Pandas. 2.2.2 is fairly current. Usually Google Colab is a little bit behind because if they go too fast, they end up breaking things. So of course we need to import pandas, and the standard way to import pandas is as PD. So we have a series. Pandas works with data frames. And you can do things with series and series, but it actually Pandas treats everything as a data frame. So as it works, very much like NumPy, it works on everything at once, which makes it very quick. So we have a very simple manually entered. This would be a series, but you can think of it as a data frame, but they pull it in as a series. And there we have it. It uses an int 64. 64 means we're storing I don't know why it's 64 bits. That just means we can have a really long, big, gigantic integer. So why would you do that in data science? Because you have huge, giant numbers you're dealing with. So that's why it's a 64-bit int. And I just printed that, and that's part of what it printed as part of it is the data type, which is interesting. In Python, our data type is 32, I think, is our standard data type length in Python. And so this is indexed 0, 1, 2, 3, 4. Looks familiar, doesn't it? Yep, just like every other array and array list in existence. However, in data science, sometimes we want to have different indexing depending on what we're doing. So we create our series, we can create our own index. Do we have to do it manually? No. We are going to do it automatically later on. So how do we access any element in the series? Well, a lot of this is starting to look kind of familiar, isn't it? If you're familiar with Python, this is a specific library for manipulating data. It just is a lot bigger and faster. Can we do Boolean? Sure. We do need to do that when we're working with data. We just want to get parts of it here and there when we're analyzing. So this is a Boolean. That means that we're testing inside the data frame. We don't have to do if and all that. We just do data2 greater than 18. It pulls everything out for us. Because this is a built-in piece to Pandas because we work with this kind of stuff a lot. Math operations, everything is carried out all at once, just like NumPy, which makes it very fast to deal with huge amounts of data. We can create a data series from a dictionary. So Pandas handles all kinds of data types coming in. And notice how we have that's probably our index, I'm guessing. So, yep. Frida has a stand that sells non-organic GMO apple. Okay, well, that's just really. Now, the display method allows us to show things very nicely without the data type in it. So we have a dictionary that has, so we have a dictionary and the elements, this is the key, the values are a list. Can we have anything over here in a dictionary as far as the value? Yeah, we can have whatever we want. Now we make it a data frame and we display it beautifully. Yep, we know about dictionaries. One thing, and this is like Linux, head and tail, gives you a sense of the data. And if you have 5,000 items in your data set, you don't need to see all 5,000 to get a sense of, oh, this is what's in here, and then I can figure out what to do next. That's what head and tail are for. 3 or 2, tail and head beginning. How do we use, what is the location method? So we're locating number, okay, where are we at here? 4, there it is. We located number 4. To get a row, we're going this way. That's not, there it is, there's a row.
433.
We can convert. Here's a one that I found someplace that imports custom countries as a dictionary. Most often you get CSV files, which we'll get to, and here's my little index. And then I look at here, all kinds of interesting stuff. I did not do comma formatting though, did I? But I'm doing head and tail just to get a sense of the data. You can sort vertically. All kinds of built-in things. I better be running this as I go, or at some point it's going to not work. I can sort horizontally. I can do all kinds of things. Pandas is a very huge library. I can sort by country name. All sorts of stuff. Here's the data access part. The most common type you're going to see is CSV, which is comma delimited text file. This is on my GitHub, so I can read it over the internet. I don't have to do a bunch of fancy stuff. Reading the CSV doesn't care where it's located. It can be located in the local file system. It can be located anywhere on the internet. And then it's a little tiny data frame. Not much to it. And then I importing JSON, which is not as common, but it is a interchange type format. Usually CSV and JSON, you'll get choices of the two. Almost always it'll be CSV. Sometimes you get JSON as a choice, but sometimes you might get just commas in a text file. Is there any difference between this and a CSV? No, just the extension. They're the same thing. They have commas between the fields and an enter mark to denote the records. So far, so good. But once in a blue moon, you'll find some weird data that has a different separator. Well, then you can put it in here. Almost always, everything I've seen is comma. But it reads Excel. So sometimes you'll see Excel files. Now, if you want to find your own data set, it used to be that data.gov had all kinds of stuff, but I don't know with what's going on, if any of those servers are still working or not. There's a bunch of things in Kaggle. It's a huge place. And we have the complete Pokemon data set, which I always thought was kind of interesting. This is somebody's GitHub thing where they've just put together all kinds of, look at all that stuff. I mean, it's all fairly old, but we're just learning on, you know, we just need some data sets. And look at this. There's all kinds of weird things in here. NFL football teams. It's old, but does it matter for what we're doing? No, not a bit. Oh my. So you can pick anything as your, because this is ultimately heading for your own data project. If you store data in your GitHub, which you certainly can, to get a link to it, I'm just going to pick this, even though this is not a data set. You have to click on it and open up the file. So you end up with, that's not right. Where's my raw? Well, anyway, it should have this format, raw.github.user.com. Why is this not doing it right? Oh, because it can't open the raw format, so this does work. But a CSV file, you'll have raw format in it because you have to actually open the file. We can't edit this file in here. Oh, I'll just do this. There we go. So previous to this, I was seeing a beautiful preview. We have to go clear in and open it up so we can see this is what Pandas is going to be importing. And you can see that as a comma delimited file. And then when we import it, Pandas lines it all up, makes it look beautiful. And there we go. And we're just doing the head. We're not doing the entire thing. And we have, I don't know how old this is when I found this. I found it someplace, IMDb movie data. Look at all that good, cool stuff. You could do all kinds of analysis on this. Oh, population by country. These are just some example data sets that I found that you could do analysis on. Because does this data all by itself mean anything? Not really. You want to figure out how to answer a question. That's what data science is about, is answering questions. Like, which country has the biggest population density? Which one has the largest land area? Which one has the lowest land area? So those are the type of things you're answering with a data science project, is a question. You can also do SQLite. I just put that in there to show that you could. Look at that. We can do SQL queries in there. Do we need to do that on our project? No. I just happened to find it and thought it was interesting. Look at here. We can get stuff, right? This is one I found that I always thought was interesting, because whoever does this keeps track of who's in space. But we can get this into here, and now it's a Pandas data set. This comes from response data. Yeah, response data.get gets the information. We want to get the people, and then this is a list. And Python or Pandas just eats up lists like nobody's business. And now we have a data frame we can analyze. Can you scrape web pages with this? Yes, I'm not going to pay much attention to that. You may want to. Scraping a web page means that you're pulling stuff from a web page and getting the information from there. It's not from a comma delimited list. So this is one I found someplace that does a list of countries by population. And it's kind of a mess, but eventually we can go through how to sorting that out. We're mostly going to deal with CSV files. So here's a alcohol consumption based on countries. Afghanistan, surprisingly, has 0, which, yeah, makes sense. Okay, there's different pieces to our data set. The data shape is how many rows and columns. So data shape, dot shape gives us this. And for some reason, I don't have the E in data frame. How many elements are in there? So this is statistics about our data frame. This is a very handy one. It gives you a summary, quick summary of what's going on in there. Oh, it tells you the memory usage too. Interesting. Describe. I like that one. Look at there. Describe automatically gives you your statistics to analyze everything. It does percentiles and standard deviations, minimum, maximum, which is pretty cool. You have what, one line of code to do all that? You just say describe. So here's a little exercise I put together. So we're getting, from somebody else. I don't remember where that came from. Oh, open data, GitHub repository, another place. So we're displaying all the data. But we're not displaying all the data because, it's doing heads and tails automatically. Oh, it must be doing that automatically because it's automatically doing heads and tails. So this gives you an idea of what the data is. All kinds of good things. Well, let's find unique values. How about that? Those are unique. Can we count them? Well, value counts. There we are. These are how many countries we have in each one. So there's an answer to a question. And then we have different data types. 64 is 64. We can, as index value, okay. This is the ISO, the standard country code for everybody. Every nation has a standard country code. We're reading this in from the URL. We're indexing it. So, this is an automatic index from the information in the data set. So this is our index now. Reading Excel, there's our URL we're getting it from. There's our index. We're displaying it just to see what's in there. And this is short enough. It looks like we aren't getting everything, but we're getting quite a few. Oh, now we're getting deeper and deeper. We can use LOC, rows and columns based on the labels. ILOC is integer-based location. So we are pulling in our information, doing country code as our index. We can then from LOC say, we just want this one. We can also say, we want number 10. I think CN is a lot more intuitive, isn't it? Because then you can just split out your information, and this is a list. So we can add in other people if we want, I think. Oh, yeah, we can. Yep, so you can make a little list inside the little brackets. So you can slice and dice data with pandas to just like however much you want to slice and dice it. And we can also do our little friend slicing. I said slicing and dicing, right? So this means CN up to NZ. This is our index, 10 to 23. We're slicing that data out and making a copy. Well, we aren't making a copy, we're slicing it out. Whoa, this is just so sophisticated. I can't keep track of everything that's in here. And there's our info. Anyway, these are just an example. We can put in different labels. Now there's so much we can use or and filtering. Oh my goodness. We can say how many have main language and in Oceania. So now we're slicing and dicing, getting down to what question do we want to answer, which was in the Oceania region, how many countries is their main language English? We're answering questions. And usually you're not going to be making up your own questions. You'll be doing like the data guys here. That's what they do. They find out, how many students came from Ontario or whatever in 1925 that were over 25 and were female or whatever. Whenever I do a NASA grant, we have to find out how many, or we used to, probably aren't going to do that anymore. We used to find out how many female, other nationality there were at the college by percentage, because they had a large, they wanted to get minorities and women into science, because there's not as many as there are male white guys. Or I like to call them old white guys, young white guys. And another one. And we can sort. So some of it reminds you of SQL. Some of it is specific to this, but it's all the same thing. And then we do more and more and more. Group by, yeah, SQL. And there's more here, but I'm not going to go through it. This does go through some data cleaning. We're not really going to do that. I left it in here as a reference. The data that you probably want to use, make sure it's clean to begin with. Otherwise, you have to do, for instance, data cleaning may be that they put, what would you say? They might put the first and last name into the same field. So you'd split it at the space, for example. So in this case, their example is kilometers and miles is in the same one. Well, that's not very helpful. We want to split it so that we have a kilometers and a miles as separate. Anyway, that's what that does. You can replace strings. Oh yeah, okay, that's all kinds more stuff than we want to go through and that you need for your, you can merge and join. I just left this in there because this is part of a big, long data tutorial, but most of this you can skip. The beginning part is the most important thing. Concat, merge, oh yeah, this goes on forever. Eventually we get down to there we go. Pandas has its own plot function. Look at that. It makes a nice little plot. And it makes nice little bar charts. And we don't even have to do much, do we? We say where it is, how big we want it, 20 by 8, which I think is just an arbitrary number. I'm not sure. I can't remember. Scatter plots are always fun. So yes, all this stuff is built in. Visual, ooh, this is like in Excel, that's the, what's that called? Conditional formatting. And that's, you can see why this is one of the big, very popular data science tools. Now, we're putting all these things together. Oh, we're doing random numbers with NumPy. I thought I had one in here that did a combination a lot. We can generate 1,000,000. Okay, these are not. There we go. So we're going to use, this is the standard way that you use Python. NumPy is faster. Okay, we don't really care about that. Here's an exercise. Finally, after all that, you don't have to go through all that, but we're going to create and display a data frame from a specified dictionary data, which has index labels. We have an index of lists, and we have labels, and your task is to put that together. Well, there's an example up there someplace. We want to display basic information about a specified. We want the first 3, the last 4. We only want the name and score columns. Video game sales. This is, I think, fairly old, but I found it someplace and I thought it was interesting. And then the next one is going to be matplotlib, which is the third component to most data analysis. And some people use other libraries for this. Matplotlib is like one that a lot of people use. And then at the end, let me go find my navigation thing. Well, let me go up there. Anyway, we have, I think we start looking at, this is just an example of different things that you can do. PyPlots, NumPy. Okay, let's get down there. We want to start thinking about our final project. Yes. Oh, it goes on, and I don't know how to get places faster. I do have a table of contents, but yeah, here's some examples of a video analysis game project. I think this might have actually been one a student did. So you're analyzing the data, you're saying, oh, look at here. I'm guessing these do not exist anymore, right? PCFX, GG, 3DO, I have no idea what those are. Those are platforms. These must be obsolete platforms. Yeah. Look who's in charge. This is older because we have PS2, PS3, and oh, there's PS4. So that's what we're looking for. And we have sales by genre. And we have sales by North America and EU, So histograms, not really tell you very much, does it? So here's your final project. Analyze the data set of your choice. You can work with somebody else or do it yourself, doesn't matter. Two people work together. Collab notebook, document a price process. Why are you interested in this data? And yep, this is only a small part of what's available. And if you find something cool, I'll probably borrow it and put it in here, just like I did with the video game one. I think this might have been a student one that they did. And I put it in here as an example. Now, after you do this,